full screen here. There we go. That should look good. Let's do this. Okay, let's make sure we're actually streaming here. We'll get into it pretty quick. Voltage Workshop. Okay. Looks like we are live. Do Streamception. Just make sure. Okay. He's there. Make sure we're actually streaming here. Okay. Well, let's start to get into it then. Happy Thursday. Happy Halloween. I didn't wear my costume today. I just about tore it up and wore it out over TabConf this past weekend. But that was fun. But nonetheless, I'm in good spirits. And yeah, ready to go over some Lightning implementation details and stuff like that. So it's pretty funny. I find that I'm always trying to think of new things to show people. New features people might be interested in Lightning, or use cases maybe they didn't even know existed. But time and time again, I get people telling me that they want the basics over and over again. A lot of people, they still haven't maybe implemented Lightning in a basic way in their own application or product, service, something like that. And so it's just that infinite barrier to entry that we have to get over is like, all right, let's spin up the infrastructure. Let's connect to it. Let's figure out the API and figure out how to use it. And so we're going to be doing that with LND and with Voltage specifically. And so that will make this process very easy for getting the infrastructure spun up. And then we're going to dive pretty deep into LND, looking at its interface, all the options within that. We're going to go through an overview of the most common LND methods. And really, that's how I ended up spending a bulk of my time. I'm probably going to turn some of the materials I have here into actually an LND cheat sheet at some point. That will be kind of like a shortcut that will get you into those basic important methods to just get you started. The LND docs are great, but just kind of starting from zero, you can get lost in them, and we'll see that later on. And then just how to facilitate Lightning payments in your product or service, right? That's the whole point of Lightning. We want to make payments. We want to receive payments. But there's a lot of nuance, like depending on what kind of business you are you doing only internal payments? Are you helping customers make their payments? And so there's a lot of considerations with that. And that's definitely where things get messy. And so, yeah, that's part of what we'll be going over. And so I guess real quick before I get started, I'm going to pull out my other laptop here just so I can look out for any questions or comments as we're going along. So just one sec. Sweet, and I'll just keep this open on the side. All right, well, let's get into it. We've got the link to the slides here and the link to the completed project right below, and that's about all you'll need. We'll be spending a little bit less time actually implementing the code. We're going to kind of take a shortcut, but we're going to grok kind of a simple, I guess, structure for adding LND methods. And then we'll just dump it all in there. So it'll be pretty simple. So yeah, be sure to have those links pulled up. Yeah, and I have the comments pulled up here. So yeah, just for context for y'all in the Discord, this is a stage channel, which is different. So they don't let you like talk live, but I can see your comments. So definitely just like drop questions as we go along. But these links should be working. Let's see. Yep, that looks correct. And then this should be my repo, which has commits on it. It looks public. Cool. Oops. Yeah, let me know if I need to turn up or anything as well. If the volume's a little quiet. It looks good on my side, so I will continue. Yeah, so these are the only two links you'll need. Link to these slides and then link to the completed project. So, and then, yeah, the repo has a link to the slides as well and vice versa. Great. So overview of what we're going to be getting into is a little bit on like why integrate Lightning. This will be pretty high level because I'm not going to try and Lightning pill you exactly today. But we'll talk about it. We're going to talk about some considerations for adding Lightning, 3 different product personas of, I guess, kind of what I was alluding to earlier, the different use cases you might have. Okay, you're implementing Lightning. You probably want to do payments, but there's 1,000 different ways that might go depending on your product, your service, who you're serving. So a lot of considerations there. Then we're going to go into intro to the L&D interface. And that's where we're going to start to understand and break down the most critical L&D methods and then implement our own as simple as possible examples. And these examples are going to be great because you're going to be able to return to them again and again as like the most, just boilerplate, simple possible example of implementing all of these most common methods. I'm probably going to use this code again and again just to start with these basic methods and build on top of them. So I think that should be pretty valuable for y'all. And if you know what you're doing, for the most part, you might just go grab the code and run with it. And that is more than valid. So that seems like a pretty good overview, pretty good set of goals. So let us get into it. So why integrate Lightning? Yeah, I mean, if you're a Bitcoiner, you probably have 1,000 answers to this question. But it's really interesting, like at Voltage, when we're talking to enterprises, different companies, different startups. A lot of these facts that we know about Lightning and the powers of Lightning, they aren't obvious to other people, and you really have to sell it because it is a very early technology, and that is one of the considerations to take into effect. But nonetheless, right, you're going to get cost savings, reduce transaction fees dramatically, which can lead to significant savings, especially with high transaction volumes. And, someone that's not working with Bitcoin at all, they might not care about this because they're not the cost savings. They're not incurring those costs of Bitcoin already. So oftentimes the strongest proposition for someone that's already locked into on-chain Bitcoin in their business in some kind of way is like, hey, how much do you think you've paid in fees? Like, it's ridiculous how much you could save in fees over time. So, so cost savings, enhanced customer experience. Obviously, this just makes that process of like sending the payment and getting the final settlement way faster and way more clear. Usually. So fast, near instant payments, improve user satisfaction, reducing cart abandonment, increasing repeated purchases, and just having a better experience overall. Maybe you're an exchange, you're servicing withdrawals or like a Bitcoin rewards app. You cannot see the screen share. Okay. Are you looking on Discord here? Let's double check our setup. Discord. Oh, I'm so sorry. My screen share got taken away. Here we go. Stream failed to start. Oh, I see. Screens. Let's see if I can do this one. Stream failed to start. I'm sorry, y'all. For some reason, it is not letting me share capture devices. No. Also share system audio. Maybe you turn that off. Yeah, I see what you're saying. Dang. So I'm so sorry. I am streaming my video successfully to YouTube and X. So that might be the way to go because I just cannot see why this bug is happening. Hide preview. No. Go live. Okay, so I'm sorry about that, y'all. We will need to jump into YouTube to see this probably. And I already checked YouTube. I know that we're showing the screen on there and showing volume. So I'm sorry about that. We got new office today, so a little bit of a new studio setup for me. But we'll get it tight and the production will improve from here, I promise. But let's continue. So we talked about cost savings, enhanced customer experience, simple ideas right there. Global accessibility, you can expand in international markets without the hassle of dealing with traditional banking fees, exchange rates, slow transfers. I mean, that's a huge bonus, right? We're global automatically. When we integrate into Lightning, we are operating and interoperating on a global network where lots of other people are. And that global network is, it is independent of your geolocation, right? It does not care about borders. And so that's very cool. Revenue diversification. You can unlock new monetization models like micropayments, allowing for incremental revenue through pay-per-click, content tipping, micro subscriptions. Yeah, so there's a whole slew of business models and payments experiences and ways that you can monetize that open up as soon as you have micropayments. Like true low friction, very, very low fee, instant micropayments. And so that is a huge unlock that so many businesses are not really paying attention to. And I think is a really underrated aspect to Lightning and something that you can do very new kinds of products with. So that is a cool piece right there. Scalability for growth. So you can handle increasing transaction volumes smoothly without escalating operational costs, making it easier to scale as demand grows. Yeah, so scalability has a little bit of a hand waving, a little bit of asterisks. We need to deal with liquidity, right? Bitcoin liquidity that is helping route and move these payments across the network. You have to balance that liquidity, deploy it in the first place. And so that is a real overhead. But once it's in place, you can deploy, 1 Bitcoin worth of liquidity on Lightning, let's just say as an example, and you can very, very easily expect to be able to do something like 5 to 10 Bitcoin in payment volume in a given month, possibly more, right? So you are deploying liquidity, but you're getting asymmetric payment volume out of that liquidity, right? So it's a huge benefit. So Bitcoin forwards, stay competitive by integrating cutting-edge payment solutions that attract tech-savvy, Bitcoin-oriented customers, potentially increasing brand loyalty and market share. So this is a true effect. This hasn't happened as much as I thought it would happen in the space, but Bitcoiners, if you are serving Bitcoiners in your business, if it's important to do that in your business, they are demanding Lightning. They are demanding Lightning withdrawals. This is becoming a standard of user experience that if you don't have it, customers, at least this specific sector customers, are like, man, it could be so much better. So that is a real consideration. For some companies, this is very, very important. They want to be in the cutting edge. But traditionally, large enterprises, right, cutting edge is risky. So at the same time, we have to make this viable, strong and secure, consistent. But yeah, these are big, huge unlocks that are, they separate you from the rest of the world of businesses and startups and products, being able to have these features, have these capabilities with Lightning. So those are some strong reasons why to integrate Lightning. Considerations for adding Lightning. You see, I didn't put a wall of text this time. I just kind of all caps was like, here's the big things that are scary and are a burden with Lightning. So we have hot wallet. It's this idea that your Lightning node is essentially a hot wallet because it needs to be online. It's connected to the network, but still at the same time, you have deployed your on-chain Bitcoin liquidity to this node. So that is a hard thing to deal with right there. You have this hot wallet, capital, right? So you're deploying the capital. You can deploy it once. You can get a lot of payments out of it, like we talked about. But nonetheless, that is capital you're putting on a hot wallet. And then that capital has liquidity considerations. Even if you have enough capital, you might need to rebalance your channels to be able to take in more inbound payments or service more outbound payments. That is a big difficulty right there. We've got server. This is the idea. This is why the wallet is hot. The Lightning node itself is a server. It's an always online server, or a mostly online server. You need to keep online as much as possible and keep it secure. So all the implications of running a high availability server are here in play. So that is there's nothing to scoff at. And then we're early. This is early technology. And so it means a lot of things. That means that there's less tooling. That means the tooling that is out there is less mature. That means that things like potentially protocol issues, bugs, and implementations, these are still things that are going to come up in the future. So it would be deceitful for me to say that Lightning is done. Lightning is set as stone. It is completely solid. You'll have no problems. It's like, no, this is still an early technology. But nonetheless, the features, the security that we have is definitely unparalleled when it comes to Bitcoin payments. Lightning is the best way to do Bitcoin payments. But yeah, these are the big problems that we need to deal with, that we need to understand. And this is a lot of what Voltage tries to help you with. We help you with the hot wallet in the server by helping you host your infrastructure, making sure it's secure. We're, of course, on top of all of the latest changes, updates, bugs. Right, so we're early right there along with you, and we also help you manage your liquidity as well. So then the only thing really left alone on your end is going to be the capital. Great. So some upsides, some downsides. So let's talk about 3 different product personas before we get into the rest of this. And so this was kind of something I set aside. I wanted this framing to be a little bit more dominant throughout the presentation than it actually is, but it's still a good way to, I think, frame how we might talk about some of these different methods that you might do. So 3 different possible product personas. We've got the web store. So this is anyone trying to sell products or services with Lightning. The exchange, anyone providing sends, receives, perhaps custody to some extent. This might be exchanges, wallets, neobanks as well. And then the innovator. This is kind of our anomalous category. Anyone doing a mix of the above services or many of the other custom offerings Lightning enables, which might be liquidity services, Lightning services, messages, machine payable API, micropayments, experiences. There's all sorts of things that the innovator might do with Lightning, but the innovator definitely probably is a little more technical and has more of a grounding on the Lightning interface. So a lot of the focus will be on the web store and the exchange. But yeah, these are just personas for us to think about. A customer that might be using Lightning, like the web store, to basically only receive. The web store is almost only just taking in payments. The exchange is doing both sides of it. And then, yeah, the innovator might be doing a mix. The innovator might not be doing almost any sends and receives. They might only be sending to a third party or doing internal payments. There's actually companies out there that their very product is to give final settlement payments to an industry that does not have final settlement payments, and they do it with Lightning. So like that's a cool example where a company might have completely internal only payments. Okay, so those are our 3 product personas. We're going to try and give them their time of day as we talk through the methods and consider how they might implement these methods differently, or which ones they might need or not need. Okay, and then we get right into the LND interface. And so this is, I guess, the real beginning where we need to start paying attention here. So the LND interface is... obviously, this is the implementation of Lightning, which is called LND, which stands for Lightning Network Daemon. And this is the documentation for it. This is kind of what it looks like if you go to it. And there's a lot in here. And so it gives people the sense that Lightning is way more complicated to work with than it is. Now, Lightning is a deep topic. There's a lot of layers to the cake when it comes to the protocol, how it's working under the surface. But for us as app developers and people making products, offering services, we really just need to plug into this interface and make some simple commands. So we're going to boil down all this complexity into a package of the most important methods for you to use and interact with. So from the top, there are 3 interfaces that you can interact with LND with once you're up and running. There is CLI, there's REST, there's gRPC. And so CLI is going to be you're in the command line, and that's good for making, these kind of one-off requests. REST is going to be the REST HTTP API, what all the web devs expect to use. And then gRPC is a bidirectional streaming protocol that allows for synchronous, am I saying that right? Yes, synchronous exchange of data. And so there's reasons you might use one or the other, or 2 or 3 of them actually. So we'll get more into that later. And then you've got all of these services. So you open up LND here on the sidebar, and you're going to be met with all, I think this is the full list of services right here. And each one of these services has their own drop down with their own dozens or more methods. So that will be the first point of friction that you might run into. So for us as beginners, as individuals looking to grok what a basic Lightning implementation will look like, we only need to spend 99% of our time probably in the Lightning service here. So that will be where almost all of the Lightning methods you need to access are. So 99% of the time you're going to be in the Lightning service. So that will drill you down in there. And once you open up the Lightning service, you'll find that there are a lot of methods. If we go to Lightning service right here, you can scroll all the way down. I don't know how many that is. That's probably like 30, 40, 50, something like that. So there's quite a few here. And then you can even break down and go into invoices service. Okay, there's some methods here that have to do with invoices, right? So that is definitely where things might get confusing. So let's dig deeper on the interface. I guess we talked about this, the CLI, the gRPC, the REST API. This is what we have as interfaces to interact with. Right, so CLI, used great for one-off commands and manual node management. And this is kind of what it would look like. You would run ln CLI, get info, or something like that. gRPC, Google Remote Procedure Call, ideal for building applications that need fast, reliable communication with LND. Example, requesting real-time payment updates in Python or Node.js. So that's an important thing to mention. gRPC, our little client that we're going to build today, is, a client. It's not a server. It's going to be in the web. And so in the web, I think there are libraries that let you use gRPC, but it's generally an interface that you'll tap into from the server side. And so, it's usually great for your server, your API, your microservice, something like that. Can have a small gRPC interface and do something like listen for incoming payments into LND or something like that. Like that's a really good use case for this kind of interface. And then our REST API, of course, you know it, you love it, best for web apps and lightweight integrations. An example is we might send a post request to create an invoice in a web app. Beautiful. So those are 3 interfaces. And from here, we can get into the top LND methods. And so now I wonder if I should show you, before we get into that, let's look at Voltage real quick. I have a node. Actually, I can keep this. I can keep this full screen. I have a node here. To get into your own node. So hopefully, I'm going to need to log in. Sweet. So I have a .NET node here, which is a free node for development that does not use real sats, but it works in exactly the same way. And so you can, we have done past workshops on this. If you go to the Voltage YouTube channel and look through the live tab, you'll see some of my past streams. There's multiple videos breaking down kind of how to get a developer node, but I'll show you really quickly. When you sign up with Voltage, which you can do absolutely for free with just an email, you will have a team. You can go into that team and you can go to create a new Lightning node. And when you're on the kind of checkout page here, you can just select a MutinyNet, and this will be completely free. So MutinyNet is a custom Bitcoin signet with 30-second blocks and test Bitcoin only for dev purposes. This is one of my favorite features in Voltage. I absolutely love it. I use these nodes all the time. And so you can continue, give it a name. You will encrypt it with a password, and then it will take about 15 to 20 minutes to spin up, something like that, and get synced up to the signet that is connected to, which is called MutinyNet. And so with that up and running, that's really good for us because we can kind of be a little bit reckless and try all of the methods, try everything out without expending or risking any of our real sats or our real infrastructure. And so MutinyNet is what I'm using, and I have, if I go into Lightning nodes, I have Austin dev node here. And this is my dev node. And so I'm going to unlock it. Cool. And so I just spun this up earlier. It took about 10 minutes for me. So if you're still in the middle of the workshop, you'll have enough time to do that and still get to the code a little bit later. And so right when you spin it up, you'll of course have a zero balance, but we can immediately go into just start getting MutinyNet coins. So on-chain, testnet Bitcoin effectively. Get 10 billion, 1 million, 100K. And then also we can get a channel opened to us and then have sats pushed to our side of a channel. So you can start out with just very quickly a nice balanced channel. And so this is such a good way to get set up for Lightning development. I mean, goodness, I've done these workshops for a long time, and sometimes it would take 30 minutes, 20 minutes just to get our Lightning development environment kind of set up to start writing code, right? And then there's lots of problems in that process that can come along as well, depending on what kind of machine you're on, what resources you have, etc. So MutinyNet on Voltage makes that so much easier. We just have this globally available testnet node with a faucet built right in. And then our interface is right here. So this API endpoint is what we'll use to make requests to our node. Of course, we have the REST port. There's also a gRPC port. And then as usual, our authorization credential, which in LND are called macaroons, we can go to manage access macaroon bakery, and you can copy this hex admin macaroon, and that will kind of be your permission. And so we'll actually do this in probably about 10 minutes when we get our initial app set up. But just so you know, this is the tech stack. This is what I'm working with, just a very basic off-the-shelf development node on Mutiny. And yeah, so free accounts get at least one free MutinyNet development node. So I know it's crazy. You could literally sign up with an email for free and then get this development node. Okay, so that is what I'm using, and that's my Voltage shill. Cool. So our node is running. We have one active channel. So it seems like a pretty good state. Okay, back into the slides. So the top LND methods, 80-20 principle. And so, I mean, we back here, like, we see all of these methods. And I remember just learning LND for the first time, trying to figure out how to just create an invoice. Took me like 20 minutes of reading to find the right method. You're like, oh, I think there's like a receive payment or something, or generate address. Yeah, there's some like on-chain methods that you can get mixed up with Lightning methods. So that's one thing that's confusing. But nonetheless, okay, we see there's a lot of methods here. And so my idea of the 80-20 principle is really you are going to be using 20% of the methods 80% of the time. They're the most important ones. And when you're new, they are without a doubt the most important ones. And so I try to break down what I think are the 80-20 L&D methods. And we're going to break these into categories, and then we're going to go over them, and then we're going to implement them all as simple as possible. I think that sounds pretty cool. And we're going to try and talk about our product personas along the way. So let's not forget about that. Which reminder on that, our product persona is the web store, which receives only the exchange, which sends, receives, maybe does custody, and then the innovator, which is doing all manner of custom Lightning stuff. Okay, so top L&D methods. We got a lot here. Let's break each of these down into a few different categories. But nonetheless, we've taken, I mean, what is it? There's 40, 50 methods in the Lightning service, and we got it down to 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's pretty good. That's probably about 20%. Okay, so the first category is going to be the info methods, which we really only had one listed there, and that is get info. Yeah, so it lets you get the high-level node and network info. And it's about as simple as that. It's something that you don't need arguments to call. It's usually the first call that you make when you're connecting to your Lightning node. It's what you do to check that you're connected and everything's running. But some other info methods you might also check out is get network info, node info, get debug info, and then fee report, which is a little bit different. A report detailing the current fee schedule enforced by the node globally for each channel. So that fee report's a good one. But besides that, these are just like, yeah, the network level info from the Lightning Network. Get specific info about another node on the network with get node info. I think that you just take a pub key. And then we've got debug info if you're having any issues or anything like that. And 1 second here, I'm getting a message from someone. I think it's a question. Okay, cool. Yeah, so that is the info methods. So pretty simple. Add, implement get info, and most of these other ones you won't need to touch for a while. And then we have the L&D channel methods. Great. So these are going to be everything that you need with channels, essentially, or almost everything. We got channel balance, which lists total funds across all open channels. So this channel balance might even be something that you consider in the info category, because it is basic information about your node. But yeah, with that category, we are looking at the channels, of course. We've got closed channel, which closes a specific open channel. List channels, which will just list all of the channels and the basic info for each one. And then open channel, which, as you expect, will open a channel to a node that you are peered with. So yeah, I mean, that's pretty basic. We have open, close, we have give us all the channels, and we have give us our channel balance. So those are those methods. So that's pretty straightforward. We can also look at these other methods you might need to peer at, which is closed channels, which returns all your closed channels from the node database. Pending channels returns all your pending from the node database. And then export all channel backups returns a static channel backup for all existing channels known to L&D. That's an important one because if you're not on Voltage, let's say, this is going to be one of the first things you want to do whenever, let's say, you add or remove a channel. Your channel backups plus your seed words are what let you recover your Lightning node if it gets, thrown into the ocean, if it gets burned down in a house fire. That is your method of recovery. Okay, so those are the channel methods. So we talked about info and channels. Pretty easy so far. On chain methods, there's a lot here. You might not need to use this through the API, right? A lot of these things you might do through a UI or something like that, such as Thunderhub. But nonetheless, I put a get info here again. It's sort of on-chain because it gives us some on-chain information, such as the block height. I think the current difficulty, some basic kind of get blockchain info type of stuff. We've got get transactions, which lists our on-chain transactions from the node database. New address gives us a new on-chain address. Send coins will send on-chain funds to another on-chain address. And then wallet balance will get the balance of your on-chain wallet. So yeah, it's very common. Like maybe if you're new to LND, you might jump in the interface and go call wallet balance, thinking that it's Lightning when actually it's on-chain. So that's kind of where things can get confusing between on-chain and Lightning. Also check out SendMany. SendMany handles a request for an on-chain transaction that creates multiple specified outputs in parallel. This is a little bit different because send coins here, send on-chain funds to another on-chain address. I should really add to it and say single output, because you can only have one output in that method. So it's kind of just think of it as like sweeping all of your Bitcoin off your node or something like that to an address. And so, yeah, the SendMany will be multiple outputs. That's the real difference there. Okay, and then peer methods. We can connect to a peer, disconnect from a peer, and then list peers. So that's pretty simple. We also have subscribe peer events, which is just a live streaming connection to listen for all of the peer events. Yeah, and so peering is something that until I started working on Lightning, I didn't totally understand. But before you can open a channel with someone, you need to be peered with them. And this peering is essentially, our Lightning nodes are all just a bunch of servers. And these servers are connected to each other in a network, okay? But before we open up liquidity channels to each other, before we open up Lightning channels with real Bitcoin, we need to be chatting over this network. We need to be talking. And so the Lightning Network uses TCP sockets, I believe, to talk. And so you will peer to multiple Lightning nodes on the network and get what's called gossip, which is kind of just network level information. Hey, there's liquidity over here. Hey, this channel that was opened over here is no longer opened. So this is the kind of gossip that gets passed around. And so when you peer with someone, you're saying, hey, I want to connect to you, to gossip with you. And then in doing that, I will be able to open a channel to you. So yeah, that is the idea behind peering. So not too much we need to do here, but yeah, there's times if we are opening channels, we're going to need to peer with someone through the API. We've got invoice methods, add invoice, which will create a new invoice to receive. List invoices will list all of the invoices created on your node, which can be a lot. We'll talk about that. Lookup invoice will look up a specific invoice and see all of its info in detail. And then subscribe invoices is that streaming connection to a database to listen for invoice changes. And so you'll also want, these are basically all the invoice methods inside of the Lightning service here. But there is an invoices service as well. And this invoices service has like 8 methods here. So you'll want to check that out. We've got add hold invoice, cancel invoice, HTLC modifier. These are a little bit advanced. Lookup invoice v2, we're going to talk about this a little bit more, but this is the new lookup method they want you to use, but something in between the documentation and the implementation is not quite right. So a lot of people have trouble with that. So we have our own little implementation of lookup invoice v1. But yeah, these are just some advanced invoice methods. I find that these 4 right here get me just about everything I need for the most part. And then we have the payment methods. These are the actual Lightning payments where we can list all of our payments sent from our node and then, of course, pay an invoice, pay a payment request that is given to us. Some other ones you might want to check out with this is decode payment request, which will take someone else's invoice. You can decode it and see all the details. And query routes, which is really cool, which attempts to query the daemon's channel router for a possible route to a target destination capable of carrying a specific amount of Satoshis. So if I'm Austin and you're Bob, maybe I want to see if I can route a payment to Bob. I'm going to take your pub key and the amount of Satoshis I want to send you, and I can put it into this method, and it will kind of try and like, is there a route? Can I get to Bob? So that's a really cool method to use. And then at this point, we would be, let's build our example app. Okay. And so that's the high level of all of these methods. Let's go back over these quickly, though, one more time and talk through our product personas a little bit. So off the top here, info, almost anyone, any product, you're going to want to use this get info method to some extent. Is there anything we need to say here? I mean, for a fee report, if you're the innovator, actually really anyone, the innovator, the exchange, and the web store, they all want to pay some kind of attention to fees. The real question is, are you just trying to facilitate your own payments, or are other people routing through your channels? And so if you just need to service your own payments, you might bump up the fees really high. But of course, if you're the web store and a user's paying you to your node, you don't want the fees to be high for them, but maybe you want the fees to be high for someone routing through your node, right? So these are some considerations, definitely. But yeah, outside of fees here, a lot of the stuff is just going to be the basic info that you keep an eye on. Make sure that you haven't split off from the chain or something like that. Okay, channel methods. So yeah, kind of interesting here. So it's maybe even only the innovator might implement these channel methods, except for channel balance, of course, because channel balance, that's just going to tell us the balance across all of our channels. But close, open, and list channels, you might not need to implement from the API standpoint, because if I'm a web store or if I'm an exchange, and even if I'm the innovator, I might be using something like Thunderhub, a UI that's connected to my Lightning node to manually manage my channels. Right, and that's a real differentiator. Like, we might talk about all these methods and say that like nearly every customer would need to use these methods. It's like, yes, that's true, but you might not need to implement these into your product, right? Do you need to programmatically be opening and closing channels through your product? Like, do you need to implement that method? Most people actually don't. And we're still in that early stage where majority of people with Lightning integrations, they're managing their channels manually. And in the future, I imagine there will be better data, more sophisticated criteria we could use to programmatically open and close channels. And yeah, people do it. But yeah, this is something that you very likely might not need to implement, even though it will be something you're going to have to play with from someone's UI, right? Cool. So channel methods, I feel like that's a good overview. Close channel, list channels. Yeah. And I guess, okay, well, here's a call. Something that you might do programmatically is you might list out your channels in some basis, like a cron job, and you might close channels that have been inactive for a long time, for example, or close small channels that are inactive, right? You might have some very, very simple criteria for closing channels that are absolutely doing you no good. So that's something really that you might do with this when you're starting out. Otherwise, this would be something you'd push towards the future. On-chain methods, let's see, get info, we talked about that. And yeah, I mean, once again, this is something that very likely you might not implement. You might do it manually. So listing your on-chain transactions from the NodeDB, that might be something you check manually. I mean, I don't know, maybe you have a microservice or something that calls get transactions and maybe some other methods and creates an automated report. That's actually very easy to build. New address, do you need to programmatically create new addresses, right? It's like, even if you're making addresses for users to pay you, do you want them to pay you to your on-chain wallet on your Lightning node, which is hot? So you almost only are getting new addresses whenever you're funding your own node with liquidity. And even then, right, you don't want a bunch of small UTXOs in that on-chain wallet. So it's pretty likely you might not surface these new addresses to users. And then sending coins, well, that's just a scary thing to automate, right? That is something you very likely want to do manually. And then we have wallet balance, get balance on chain wallet. So yeah, that's something almost everyone, might want to have, just a top level method that gets fired when things start up, or maybe once a week. But once again, every single UI that connects to your Lightning node is going to show you this stuff. So yeah, okay. So far, for all three of our user personas, there's not too much for them to do. It's like we have some info here. We have balance. Maybe we're going to have some criteria to close our channels. Maybe we're going to have some criteria to pull transactions. And then we're just getting our wallet balance, right? So pretty straightforward so far. L&D peer methods. Same consideration. Are you needing to peer programmatically with people? Possibly the innovator will, allow their users to peer with their node or something like that. Or vice versa. You might peer with a user. So it's possible you might do that. It's possible you might have some cron job to add or disconnect peers based off of gossip. But that's so advanced. It's very unlikely. For the most part, you're going to be doing this stuff manually. But yeah, subscribe peer events. Hey, maybe when you spin up your Lightning integration, you're going to start collecting a bunch of data. This is a great method for doing that and getting a bunch of gossip data. Maybe you're training an AI on gossip data. So that would be something you might plug into if you're the innovator. And for the exchange, the exchange now, you're going to be doing that stuff manually. And for the web store, you're just trying to receive payments. You just need to be well enough connected to receive payments, right? So you're not going to be in the peer network all the time messing with your peers. Invoice methods. Everyone's going to be using this. So we got add invoice, first of all. So this is going to be the web store. Whenever you want someone to pay you, you're going to create an invoice through add invoice. The exchange, whenever someone is going to deposit, you're going to create that invoice. And the innovator, whenever they need to create an invoice to be paid. So just goes without saying, this is one you were going to implement. The exchange, you're going to have some kind of UI where when the user's on a screen, this method gets called, that invoice gets popped up. The web store, you're going to want this BTC pay server type of experience where they go to the checkout page and they go to pay and that new invoice pops up and, there's a little timeout under it for when it expires. And so this is that one method that you need to make that experience. We then have list invoices, lookup invoice, and subscribe invoices. And I'm going to talk about all of these kind of in one grouping because these are going to be the methods that you're using when you're checking if you have been paid or potentially some other events on invoices. For example, if an invoice is expired, you might be able to listen for that on subscribe invoices. But this is a very common scenario. So the web store, someone's checking out at the web store, an invoice pops up, the user scans that invoice, and they're going to go pay it. But then you, as the web store, you are using one of these methods, probably either lookup invoice or subscribe invoices, to look at that particular invoice. Because you just added an invoice, you created it, the user's going to pay it at some point, and so you're polling this lookup invoice endpoint. Hasn't been paid, has been paid, has been paid. Or you're listening on the subscribe invoices stream, just waiting to say hasn't been paid. And then, okay, it's paid now. Boom, show a success confetti for the user so you know everything's good. So that's an important experience. Not even experience, just a requirement that you must have. So that's one of those things you got to get around. It's like, are you going to subscribe to invoices? So subscribe invoices, once again, this is something that's only on the gRPC interface. Are you going to implement this in your server-side environment or your microservice and listen to that in real time? Or are you going to pull? Are you going to pull the endpoint? So that's some overhead there. But yeah, that's basically all that the product personas are going to do in this category is create invoices and then find ways to listen for them to be paid and update whatever records they need to based off of that. Now the payment methods, we've got list payments, SYN payment. Pretty basic here. I actually didn't look here in the invoice as service. Yeah, I mean, I guess it's worth mentioning cancel invoice, right? You might be the web store, the user leaves, you might cancel an invoice. Add hold an invoice. We're not going to talk about hold invoices. And subscribe single invoice. I actually forgot about this. So this is a really good alternative to subscribe invoices, which gives you all invoice events. Subscribe single invoice is probably a lot more viable for that streaming connection, listening for changes. Okay, cool. So back to the payment methods. For our personas, let's see. For both, so the web store is out of this discussion because you're running the web store. You are probably not sending payments, programmatically at least. You're maybe withdrawing your payments and sending them to yourself through some UI, but that's about it. So the web store is probably good on this part. But from the perspective of the exchange and the innovator, there will be times when they need to send payments. And not only do they need to send payments, they need to do it programmatically. That's a little bit scary. So there's some considerations in there. And then listing payments, this might be something you implement to check yourself, to check your records. Maybe you keep duplicate records of your invoices or something like that outside of your Node database. So yeah, we'll go more into detail and like send payment. There's really one gotcha with sending. I shouldn't say that. There's one gotcha that I like to point out with sending payments. There's many things that can go wrong, but with a very basic implementation, you really just need to make sure that you verify the payment request, decode it, right? That's a good thing to use before you send out a payment. And then also you need to make sure that you're setting a maximum fee so that you don't get fee siphoned. And we'll talk about that later. So yeah, the exchange, the innovator, they might want to implement these. We've got query routes. This will be a good one for both of them as well. Before they send that payment, especially if it's larger payments that you're sending, querying routes is very important. It can help you have a better user experience because you can communicate to the user like, hey, I'm trying to find a route. I'm trying to send you this payment. Here's what's happening. Versus maybe just starting a spinner that never stops spinning. Cool. All right, so we kind of talked through each of these with our user personas. We went through them twice. Goodness, you're probably an L&D expert already. But yeah, really our very big important customers here, products, the scope of their businesses are so large, but at the same time, there's really a handful of methods here that are really key to our business logic that we're going to be implementing. So let's get into it. Let's build our example app with React. And so we're going to be using Vite to create a new React app. And you can go ahead and run a command like this, npm create Vite at latest. And yeah, and you should see, the link to the slides is in the top right over here. And then the slides have a link to my repo with the completed project as well. But I'm just going to follow along with you all, and I'm going to go copy this command right here. But I'm probably going to rename it because I already have something called that. Okay. So I'll paste this in. I'm just going to call it Lightning Workshop. Okay, and it's spinning up, and there we go. I can just cd Lightning Workshop, and I'll say code dot. It always gets rid of my code command. That's okay. We'll just open it the lame way through Finder here. Where was that? Lightning Address Workshop. Express. I'm sorry. Voltage Developer Workshop interface. Oh my gosh, I'm so sorry. Okay, let's find this Lightning Dash Workshop and desktop. No, it was right there. Okay. Okay. Very cool. So this should be a blank Vite React app here. Seems like it. And let's just go ahead and we'll npm I and we'll npm run dev npm I. And I'll be sure to zoom in a little bit here so you can see and get everything installed. And I'm also remembering you will need to install one package. I'm not sure if I tell you to install it. Yes. Okay. So we need to install, first of all, I'll get rid of that. Transparent. Also install Axios, running npm I Axios. Cool. I'll go ahead and do that in npm I Axios. And this will just be the library that we're going to make for our HTTP requests. And so here we are going to be using exclusively the LND REST interface. Okay, great. So this is in place. And now really simply, we're going to create a new file, lnd.js. So I'm going to grab and copy all of this code here. Go in our code editor inside of source. I'm going to say lnd.js. We'll paste this in and let's walk through this code. And so here we are using Axios and we are importing two environment variables. So these are for LND. This is all that we need to talk to our node. Our macaroon is going to be our admin macaroon, and that will be our permissions token. And then of course the host is where we're requesting. And so we will create a new Axios instance called LND with axios.create. And that base URL will just be our host at port 8080, which remember is the REST port. And then you can see in the headers, we have this gRPC metadata macaroon, which is just a fancy way of saying, hey, here's my permission token. Here's my macaroon, and we're putting it right there. And cool. And so with this LND instance, we can now reuse this to just call each endpoint we need. And starting with the info methods, I have the first example for you here, which is getinfo, where we very simply, we try and catch, we get a response, lnd.get at v1/getinfo, and then we're going to console log that, and we are also going to just return it from here. So that's kind of the simple template for implementing these LND methods. So that's a pretty nice start. So lnd.js, we spun up our new Vite React app. We've installed Axios. Okay. And so next we're going to add a .env and add env variables. And we're also going to add .env to getignore. I'm looking out for you. And so this is going to be environment variables, which are just our secrets that are going to live in our app, but we want to keep them as hidden as possible as we use them. Here's where I'm going to say security warning. We are using, once again, maybe you weren't with us before, we're using a testnet node here on the MutinyNet signet. So this is a test node with fake sats. And so normally you really want to think twice before you bring your admin macaroon from a mainnet node into a web project like this. Be very careful. In a server environment, it's very different, protecting secrets, versus here in the web environment. So I just want to call that out so I'm not showing you something that is a bad practice and insecure. But okay, nonetheless, let's make our new file .env, which will hold our environment variables. And then in getignore, look at that. Like, why do they have a getignore if there's no .env in here? There's an everything.local, so if I named it .env.local, it would... Okay, but anyway, maybe that's just what I should do. rename.env.local. I'm just too lazy. And see now if I get status, oh yeah, I would need to get init, get status. Yeah, now it's ignored. So, okay, well, I suppose that's what I should do. Okay, let's remove all those changes. Oh, I didn't mean to do that. Oh my gosh. Wait, did I? I think it just broke everything. Oops. Well, let's run that command again. Watch this. I'm going to go Lightning Workshop -2. We'll pretend it never happened. Okay, now let's go back and grab this, and then we'll pick up from where we were. And npm I Axios. Okay, cool. Back to the env.local, and we'll add our environment variables. Cool. So, and we're gonna have vite_host. It's gonna be our first one here, which will be our LND host. It's actually, I believe it's vite_voltage host. And then we'll have vite_macaroon, which is kind of a fun word. Let's just make sure. Vite voltage host. Yes, that's correct. Cool. So those are the environment variables we're expecting. So now let me go back to voltage, and I'll grab those from my dashboard. And so first of all, the API endpoint here, that will be our host, which we just call it API endpoint in our UI. And so that should look good. And then I'll go into manage access, macaroon bakery, and I can click right here. And we need to be sure to choose the hex encoded macaroon. It's almost always what we use in Lightning, is, or at least in LND, it's the hex encoding for macaroons. And I'll put that there. Beautiful. Okay, so that is in place. And we're going to have one more addition here before we test our basic logic. So add environment variables, we did that. Add .env to .getignore. Somehow went horribly, but we basically did that. Now we're going to update app.jsx. So let's copy this. This is the biggest slide of code. Let's copy this, paste it in, and we'll walk through it. So I'm just gonna, I've got app.jsx here. I'm gonna just go over everything, paste it all over, and we should have our new app. Nice. Okay, so we see a lot of red here, but it's only showing me this because these are variables that have been created, but they're not being used, which is fine. That's fine for right now. So very simply, what we have here is basic app component. And we are importing everything. So that star symbol means everything as LND from ./LND. So we're just importing anything that we add into there is getting called LND inside of here. We are setting aside state for our data. We're setting aside state for forms because some of these methods we're going to use are going to require forms, very basic forms, a few inputs. And then we have our implementation of handle get info. So specific handlers for different operations. And so when handle get info, you see that we try to get a result equals await LND.get info. So all that we're doing, we're calling LND from inside of LND, and then this get info is what's getting called. we get a result and we just set it to info. That easy. And then we give the user a little alert if it's successful or if there's an error. And then in our UI code, we see that there's just a section. And that section allows us to get info or refresh it. Cool. So now at this point, we should be able to npm run dev and start our app. Let's see if it works. Okay, it's beautiful. You can see we made a dark mode by default. But let's go ahead and open up the console here so we can see how things are going. And let's hit our first method. Let's see how it goes. Okay, I get an alert, node alias Austin dev node. Here's my pub key. And then it's just going to dump all this info down here. Beautiful. So we see all this high level info, our color, our channels, number of peers, block height, block hash. Is there difficulty? They don't have difficulty on here, but that's okay. Sync to chain, true. Sync to graph, true. And then we see chains. We are on the Bitcoin chain on network Signet. So we know, okay, these definitely aren't real stats we're playing with. So nice. And then we can hit this and it'll just refresh it. Beautiful. Okay, so that basic piece works. And so we just added that app.jsx. And with that, basically, we have a template for all the methods that we want to build from here on out. So yeah, I kind of just tried to boil it down, separate the code, but boil it down into the most simple process to where any L&D method you want to add, we can just add in this giant kitchen sink of examples. And so for each method you want to add, you just need to simply add an API call with the minimal params in lnd.js, right? Oops. All right, so we have that here with getInfo. We're just try catching and we're just literally calling the API. You want to add UI/button/form in the return of app.jsx, right? So whatever you need to show the info doesn't require any input, so we can kind of just, yeah, we do json.stringify here inside of a pre-tag. And then we have a button to start it up, and it's like, okay. And then also a handler for submit and the fetching of the data in app.jsx. And that's what we have right here. And so there's basically our process. Add the API call, add the UI, add the handler. And that should just kind of be a generic way of building up all these API endpoints. And so to make things simple, originally I had us just like adding in each one of these methods manually, but I realized that's not very fun or helpful. So we did one and we saw how our pattern is going to work. We see it working. So what we can do is jump over to my repo here and copy over app.jsx and lnd.jsx from that. Yeah, so let's do that. I should be able to jump over here and go to, where did I put that? Here it is. Yep, here's my repo, and this is, yeah, 2 commits. This is the latest commit. Actually, it's not. Add links 1 hour ago. Okay. So I'm going to grab app.jsx here. I'm going to copy this entire thing and dump it into here. There will be a bunch of stuff. And then we'll go do the same for lnd.js. Okay. And our overall structure is still the same. We start with info methods. I actually added links to each API call. And then we go into channel methods. Then we go into invoice methods, right? So everything's here, everything that we went over, all in its most minimal form. And then here in app.jsx, we see our state was already here. And all there is now is there's just handlers for each one of these. Whole bunch of handlers. Whole bunch of handlers. And then we have different sections. We have an info section, channels section, which we see like the channels. There's some forms here. There's some stuff going on. And then we have invoices section, payments section, and then peers section. Oh, and wallet section, right? So that's kind of, it's called wallet section. Really, that should be called like on chain, because that's what we called it before, on chain. Cool. So let's see how this looks if we go back to our app. Is that right here? Yeah. And boom. Okay, we are presented with a full page of options. And so let's start to go through these, and we'll look at the implementations and maybe the docs a little bit. We're actually already over time, but let's at least go through these. So let's list channels, and this should work. Found one channel, and then it'll just dump it all down here, which there's only one single channel. And of course, I have a button to close that channel. Yeah, we see a total capacity. We see it's active. And so that's very cool. Let's see if there's anything I want to point out with channels here. Got list channels. This is straightforward. It's just a GET request. Open channel. Yeah, so we have a few considerations here. We can go actually open this in the browser to the open channel. And so for all of these, we see like here's an example request body. There's all of these possible arguments you might pass in, and there's very nice descriptions here for them, but it doesn't always tell you what is required, what is not required. That can be confusing. That's why it's nice to have these minimal implementations. We know at the very least this is all that's required, right? We have a node pub key string, so this needs to be a node that we are already peered with, like we talked about, and then we're just choosing the funding amount that we want to, basically the size of the channel, right? And you've got other options like private, true. Is this still called private in the API? I wonder. Base fee rate. It is still called private. Okay. Yeah, so private will mean it's an unannounced channel. And then push option, right? We get the option to, as we open up the channel, push some sats to our peer. So that is a cool thing you can do, but pretty basic there with open channel. We got list channels, closed channel. And okay, so kind of an important point here. We're doing a little bit of formatting because we're basically putting in info, the channel point. And so the channel point, we can actually see kind of what this looks like in the UI. It'll make it a little more simple. If I go to list channels again, your channels, okay, we see we have the pub key of the channel, and we have the TXID and output index. And so all that is where was I? That's something like this, where this first string right here is the TXID of the channel open on chain. And then we have the V out of that, which is basically just the index, because, you know, outputs can have multiple, a transaction can have multiple outputs. So you need to know the index of that output. So that's simply what this means. So that's really all that we put into our form is that string. And then you can see here, we're splitting it by the colon, semicolon. And then, yeah, all we have to do is call the delete to slash the funding TXID at the output index. And we also have the optional argument of force. And so a force is not a dangerous option, is a forceful option where you're basically saying to your peer, I don't care what fees are, I'm closing it right now. I'm basically taking my what do you call it? I'm pushing the eject button, and I'm just paying the fees no matter what. That's kind of what a force is. And so you definitely don't want to force close by default. Maybe the innovator does. Maybe that's how he innovates. But in general, yeah, that's going to be an option here. You can see we're defaulting it to false. Cool. So that's some channel stuff. Should I open a channel? So I can actually open a channel. We've got MutinyNet open here. So if you go to mutinynet.com, you can see the full mempool and block explorer for this SIGNet. And there's also faucet.mutinynet.com, which is the Signet faucet. And so something we can actually do here, I can go, yeah, so here's their faucet lightning node. I can go take this string and open a channel to them, or I should be able to. And node pub key. Oh, so I only need the node pub key. I have more information on here actually. So I can delete everything after this at, right? Just have their node pub key, and let's say 100, well, how much do I have? Let's do 50,000 sats, something like that. Channel opening initiated, funding TXID is undefined. Well, okay, well, we see it here. It looks like it's just base64 encoded. Cool, so that should be started. And since MutinyNet has 30-second blocks, this should happen pretty fast. In fact, I bet our transactions right here because there's 2 transactions in this block. Yeah, look at this, 50,000 sats. So this is our output right here. And so it should get mined pretty dang quick. And then we'll see our new channel reflected. And so that's kind of an example of opening a channel. We could then close that channel. So maybe let's refresh. Let's see if it's open yet. Found one channel, so not quite yet. Another block went by. Still one channel. Okay, we'll close that channel in a second, but let's go to invoices. We've got list invoices here, which, oh, there's actually 0 invoices. So I've never created an invoice. So that's actually a good next thing to do. Let's create an invoice for 21 sats. We see it right here. I can copy it. I need to format that better so it's easier to copy. Let's refresh. And now if I list invoices again, so look, the invoice is here, but it's not paid yet. So this might be an example of what it would look like if I'm polling. I'm waiting for this to get paid. I'm looking at settled. Settled is still false, right? Now let's make settled true. We can go to the MutinyNet faucet here and have them pay our invoice. So I can paste this, strike me now, pay the invoice. Here's your proof. Go back to the app. Let's list out these invoices again. And settled true. So it worked. So we have 21 more sats. Thank you, MutinyNet. Okay, let's list out the channels again. We should have 2. Yep. And then we have our tiny one, 50,000 sats. And then another one looks like 75,000 sats. Cool. So I can actually just kind of close the channel with this button. Or we can see here, I would put in the channel point, which is the TXID/output index, which is literally just this thing that we are looking at before. But let's just go ahead and hit this button. Let's see if this works. Close channel. Error closing channel. Did I maybe hit it twice? Maybe I hit it. I did hit it twice. Maybe I should have waited. Unable to gracefully close while peer is offline. Okay, maybe we broke it ourselves. List channels. Found one channel. Okay. So it actually worked. We just hit the button twice. But hey, there's a really good actually scenario to call out. This is a good one for like whenever a user can manually create invoices, like disabling that button, make it barring the user from just creating infinite invoices in your database, or accidentally creating multiple when they're trying to create one. That is a good thing to look out for. We see we ran into that mistake a little bit. Okay, so we've paid an invoice, we've opened a channel, closed a channel, created an invoice. Let's look up our invoice. So I've got our invoice right here, and so I can, where is that? Look it up right above here. And so to look up invoice, you need the payment hash, which is called the R hash here. And so this is actually base64 encoded, which is not what we want. If we go and look at the code, I want to show you this because I've helped so many people with this exact method. Look up invoice. We're taking an rhash string, and I'm checking if it is base 64, then I actually want to, so if it's true, then I want to, looks like we're iterating over it, and I want to turn it into a hash string. Otherwise, we're just going to assume it's a hash string. And then, yeah, we take in that hex hash. And so here I'm putting in base 64, and if I hit lookup, invoice found, value 21 sats, settled yes. Beautiful. So it works, and we see the full response down here. All the full responses are coming down here at the bottom. Beautiful. Okay, so we can look up our invoice, we can create it, we can list them all out. Nothing else too customer special with the code implementation to look into those. We've got payments. Let's list payments. I think there will be 0. Yep. Empty object. So let's get something to pay. Once again, from faucet.mutinynet, we can get an invoice, but we actually have to go to their endpoint, their LN URL endpoint on their staging instance here. So you'll have to go to refund. Yeah. I should copy this. I'll put this in the slideshow. Let's test it all. Let's test it all out. Okay. Get invoices to pay from here. Cool. And so this has a hard-coded amount of 1,000, which is millisatoshis, which will actually be 1 sat. So you can change that amount. But yeah, we got that here. So I'll go back to my other browser. I see I have an invoice here. And I should just simply be able to paste it in here and make that payment. Pay invoice. Oh, I renamed. Ooh, we found a bug. We found a bug. That's good. It was originally called pay invoice. We changed the name to send payment because that's what's called in the API. So where is that? New address, get transactions. Send payment. So app.jsx has pay invoice, handle pay invoice. Okay, this is what needs to become send payment. There we go. So that was a little bit of a bug fix there. So I'll fix that in the final repo as well. Let's try that again. Okay, there we go. Payment sent. There's the payment hash. So we can now pay invoices as well. I can list out this payment, and we can see the kind of very similar but somewhat different structure of a payment that we send out versus a payment or an invoice that we created, rather. Okay, finally, let's list out peers. There should be one peer here. I could disconnect from them, but that would be a bad idea because they're my only one. And you can find new peers if you go here to mutinynet.com. You can go to the Lightning tab, and there's not that many nodes, but you can like go click on the map here and just go find different nodes, and they'll have this connection string, which you can use to connect with them. And then I can kind of just jump around and see which ones they're connected to and see which ones they're connected to. So that's a good way to find peers to kind of test that out. But yeah, I mean, pretty simply, all you need is the pub key and the host. Let's go ahead and try it. Let's connect with someone. Faucet LND seems legit. I can take this. I'll paste it in here, but everything after the @ symbol, I'm going to delete the @ symbol. I'm just going to copy that, and it's going to be separate. Oops, because this is just going to be the pub key. Is this the same? This is the same peer I already have, actually. So I need someone else. I need to find, like, this guy. Who's this guy in Washington or something? I can't click. Flash sats. Let's try this. So get everything after the @ symbol and delete the @ symbol. because that's our host. It's just an IP address at a port. Something's happening. Peers. I got a 200. Let's see if it worked. We should be able to hit list peers again. Found one connected peer. Okay. Connect. There is no response. We are getting a 200, but there's no response body. Let's refresh the whole thing, and then we'll... Ooh, error connecting to peer. Request aborted. Okay, so maybe it was just taking a second. But nonetheless, we know we formatted it correctly. Finally, we have the on-chain stuff where we can get balance. Get our balance. Yeah, our on-chain balance there. We can list transactions. We should have at least one on-chain. Okay, there's 6. Wow. Oh, yeah, of course, we've opened up a channel, so that counts. We've got all the details of those down here. And let's generate a new address. And we can receive to this. We can get some sats from the faucet again. And we should see our on-chain balance go up. So yeah, give us 1 million sats to this address. And now I can actually view this inside of, yeah, the transaction here exactly. So that's beautiful. And then within a minute, we should see that balance show up. But of course, we have to wait for it to confirm, which will take some seconds. Let's send coins, though, because we can still go ahead and send to them. So let's grab the on-chain address here. And let's initiate a send of, you know, I don't know, like 3,000 sats to this address. We can choose sats per byte optionally. Let's do 3 sats per byte. Can send. Transaction sent. Here we have a TX ID. And I should be able to find that in here as well. In the search bar. Nice. One confirmation already. Yeah, and we see my output right here. 40,000 sats that's going to them. Cool. And if I get balance again, it should be a lot bigger. Yes, it's a lot bigger. So we got that million sats. Beautiful. Okay, let's take one last scan in L&D. I just want to see if there's anything else. Oh, yes, with send payment. Okay, I alluded to this before. So sending a Lightning payment. It's a very simple request, but I have this comment here. You should set this to prevent getting fee sniped / siphoned. Right, so you want to have a fee limit here. I have it fixed to 1,000. Let's look at the endpoint and see. This is send payment. Let's look at the arguments. Fee limit. The maximum number of Satoshis that can be paid as fee. Okay, so that's not millisats, so that's 1,000 real sats. And we see in the fee limit object here, it's just a fixed MSAT or percent, which is actually pretty cool. It's cool that you can choose a criteria like that. So yeah, just make sure that you set a max on this endpoint. Otherwise, if you're the exchange, if you don't set a max fee and you're in the exchange, here's what I'm going to do as a user. I'm going to go request withdrawal to my Lightning node. And there's going to be only one route to my Lightning node. And the fees on that route are going to be so high, I might be able to rob you of more money than you would believe. And so these attacks happen. So this is why you want to set a max fee on this piece right here. Okay, so I'm glad we returned to that. Let's look at the on-chain stuff again. Got wallet balance, that is straightforward. Get transactions, that's straightforward. New address. Okay, we're choosing a type here for addresses, so that's worth considering. It looks like we're using a witness, pay to witness pub key hash. But yeah, that's the only param we're passing in here is type. Let's go see that on the API. New address. LMN. Okay. So we have address types. Yeah, okay. So looks like you can do a number or the name. Taproot pub key and use Taproot pub key. Okay, cool. So yeah, probably you'll want to do the same. Yeah, either witness pub key hash or witness script hash would probably be good. So that's new address. We've got send coins, address amount, sats per byte. We saw that. That's pretty straightforward. And then our peering methods where we list, connect. We kind of saw with the form, the connect, we have an address that we're connecting to and it's split up. And then we have like an optional permanent if we want it to be a permanent peer. That should maybe even default to true. That is true would probably be a good default there. And then disconnect peer, which just takes in a pub key. We don't need the address, obviously, because we don't need to find them. We are already connected. Okay, cool. Amazing.